Multiple choice questions on transformers. First 5 to 6 questions are basic, so if you are known to the basics, means you can skip directly to the 7th or 8th question. From there important questions will be started. First 6 to 7 questions are basics. Okay, first question. Transformer works only on dash supply. As we know that transformer we used only for AC supply. This is a general question which is only used for DC supply. What happens if it is connected to DC supply? I will tell in another question. It is only used for AC supply. So answer is only AC supply. Next question. Primary and secondary of a transformer are. Primary and secondary of a transformer are options: electrically coupled, electrical and magnetically coupled, magnetically coupled. Here we can see this in this image. This is the primary winding and this is the secondary winding. These are not means physically connected, that is electrically connected, but they are connected through an flux, means which is a magnetic path. So we can say that it is connected through a magnetically coupled. We can say that answer is magnetically coupled. Okay, a transformer is an effective device because, as we know that induction motors and other electrical equipments will having a rotating part, and there will be a huge amount of losses, so that most of the motors efficiency lies between the 60 to 75%. But in case of a transformer, there are no moving parts, only because it is only as a station, it is a stationary part, so the efficiency will be high. The losses will be less in the case of compared to the transformer than the compared to this motors. So its efficiency is high because due to its static device. This does not consist of any moving parts. So a transformer transform TF means transformer, so short form. A transformer will transfer electric supply from primary to secondary with a change in dash. As we know that transformer will step up the voltage, step up and step down the only the voltage, not the power, not any nothing current. As the voltage increases, current increases, as we know that like that depending upon the load the voltage will going to change, and on the secondary side of the transformer. So the transformer will only changes the voltage, not the power and other stuff. Voltage per turn. Next question, fifth question. The voltage per turn in primary is dash the voltage per turn in secondary. Okay, what they are asking means, this is the turn, consider this one as a single turn, this one as a single turn, and this as a single turn. The voltage in one turn in primary is dash times the voltage in one turn in the secondary. The voltage will be same. The voltage can be step up and step down only depending upon the number of turns. If the number of turns are more, then the voltage will be high. But if the number of turns are less, then the voltage will be low. But the voltage in this turn will be same as voltage in this turn only. Okay. There will be a small negligible amount of losses, so it can be neglected. So that voltage in this turn will be almost be equals to the voltage in the secondary turn. So it can be considered as same. Answer is same. Voltage will be same in both primary, as means per turn, not primary winding, secondary winding, only per turn. Next. Okay, the winding of a transformer with a greater number of turns is called, as I said earlier, if the winding consisting of a more number of turns, if this one has a more number of turns and this one has a less number of turns. This is from the distribution station. Near distribution, consider we are supplying a electric supply to the consumers. In distribution transformer, the primary side will be higher. Okay, this will be about 11 kV, and where in case of consumer sites, that is which are connected to the roadside or near the house, this will be about 230 kV for a single phase transformer. Okay, 230 kV. So number of turns in this will be more because the voltage is more. In order to get a lower voltage, the number of turns are reduced. So answer is the winding of a transformer with greater number of turns will be high voltage winding, because as I shown in example, 11 kV will be having the more number of turns than the 240 kV. Next question. The iron core is used to dash of the transformer. Why we are using iron core in the transformer means there are two types of transformers. One is iron core transformers and another is air core transformers. Coming first, I will tell about air core transformers. If we remove this core and only windings are present, the flux will link and the flux will links with the consider flux is linking with the secondary winding, but there is no this iron core. Then what will happen means the air will be high. It will air will be act as a high resistance to the flux then compared to the metal. Metal will be acts as a low resistance, where air will be acts as a high resistance. So mm, we can say that iron core is used to increase the magnetic coupling capacity, like that. For that, iron core is used. So it is used to provide a tight magnetic coupling. Answer. Okay, next question. If a transformer core has a air gap, then dash. As I say, as consider there is a crack here. What will happen means the resistance will increase. Okay, the current drawn by the primary side will also increase. Well, consider this is an open condition. Then current drawn is I naught. That is primary current will be higher compared to this compared to the normal condition. So we can say that magnetizing current will be higher when in case there is any gap between the core. Answer is magnetizing current is greater. Next question. Okay, maximum flux produced in a core of a transformer is dash. Directly proportional to the frequency, inversely proportional to the frequency, inversely proportional to the primary voltage. We know the transformer equation. I will write here only. E is equals to 4.44 into F into N into 5. Here we can see that the maximum flux produced in the core is in the transformer. This is the pi is the flux. Okay, what happens if you transfer this one means E divided by 4.44 into F into N. So the pi will be inversely proportional to the frequency. So this for this the reason maximum flux will be produced. Maximum flux is flux produced in the core in the transformer is inversely proportional to the supply frequency. From formula we can say that answer is B. Okay. The flux in the core of a transformer is dash. As I said in first question, the transformer works only on the AC supply, so the flux will be purely alternating one. If the flux is purely power supply is alternating, so the flux produced is also alternating one. Okay, next question. When the primary of the transformer is connected to the DC supply, what happens? If this side is primary is connected to the DC supply means what happens means the direct current will be having a no frequency. So the current will start flowing in this but does not produce any magnetic flux or linking with any secondary winding. Due to the lower resistance, larger amount of current will usually this will be of a thin wire. So what happens means larger current will start flowing. As a larger current starts flowing means the temperature will increases. There is a chances of the primary get damaged. So primary will get burned. What happens means when connected to DC supply, a transformer is connected to DC supply, primary winding will burn. Okay. An ideal transformer is the one which dash. Ideal means this ideal transformer is used for study purpose. Similar to the practical transformer, difference is that in ideal transformer we are not considering any losses, but in practical transformer we are considering this losses. So it does not have any leakage, reactance and winding resistance. It doesn't mean we not using the ideal transformer. Only for study purpose we are using ideal transformer. Okay, next questions. Okay, problems. A low voltage outdoor lighting system uses the transformer of 120 24 volts slash 120. Its primary is 120, 24 volts is secondary, which is connected to the lighting system. The equivalent resistance of all low voltage lamps is 9.6 ohms. The load, consider this 9.6 as a load, that is light equivalent. They are given the equivalent resistance of the load. What is the current in the secondary coil? So assume no losses. There are no losses. We can directly put that. Okay. V. What we have to find? Current in the secondary coil. Okay. Current in the secondary coil. Here they are given voltage and resistance. So directly we can say that I is equals to V by Z. So from this we can say that I is equals to V is equals to 24. 24 divided by Z. Z is 9.6. So I can say V is 24 divided by 9.6%. So answer will be, I will do it in the calci. Okay, 24 divided by 9.6 will gives you 2.5 is the answer. Answer is 2.5. If you want, you can check the answer. For okay, so for same question, for this same question, they are asking what is the current in the primary coil. They are asking what is the primary current in the primary coil. So we can find this from the previous answer only. We know that these are the basic formulas of the transformer. You can, if you want, you can write it down. I1 is equals to caps. I1 is equals to K times of I2. K times of I2. I1 is equals to K times of I2. What is K means? Where K is equals to N2 by N1 or V2 by V1. In this case, they are not mentioning the turns, so we are considering V2 by V1. So 24 divided by 120 means 24, 120. Okay, 20, 124. It will be 0.2 into I1. I1 is 2.5. So answer will be 0.5. How means I1 is equals to K times of I2, where K is equals to V2 by V1 or N2 by N1. Here they mentioned voltage, so V2 by V1, where V2 is equals to 24 divided by 120, which will give us the 0.2 value. And when we can multiply, place this 0.2 value here, even and we have to place the previous answer. This is 2.5. 0.2 into 2.5 will give you 0.5 is the answer. Okay. Next, for a same question, for a similar question, that is question number 13. How much power is used? We know that power P is equals to V into I into cos pi. I will write it properly. Space into I into cos pi. Okay, cos pi. Here the cos pi we are considering, assume they are said the values are assumed, here the no losses considered, so we are considering cos pi is a unity, power factor is unity. So remaining what we have to find? P means voltage. What about the prime? What about the voltage is? Voltage is about 24 volts. Okay. What is the how much power is used? In secondary side, how much power is used? 24. 24 into current is on the secondary side is in this 13 question we have found that it is 2.5. Okay. 2.5 into 24. 24 into 2.5 means twice of the 24 is 48. 48 plus 0.5 means okay, 48 plus 12, which we will get 60. Answer is 60. Okay, place this voltage value and the current value of a secondary side. The cos pi is equals to 1. You will get the value of the power. Next, a transformer has an efficiency of 80% and works at 100 volt 4 kV. If the secondary voltage is 240 volt, find the primary current. We have to find the primary current I1. Here they are given same form. We are using same formula. P is equals to Vi cos pi. Here also same formula. We have to find I. So P divided by V. Here they are given value of P. P is equals to 4 kilowatts. So 4000 divided by 100. Okay, 4000 divided by 100 will give you cancel 0 cancels, which will be value of 4000 means 3 zeros divided by 100. I cancel 2 zeros, so remaining will be 40. So answer is 40 amps. Just we have to cross multiply this. We will go below the P, so I value will be obtained. So cos pi is the value 1, so need not to be considered. Okay. Next, question 16. For this question, what is the secondary current? They are asking for secondary current. Okay. Here we have found the I value. Sorry, I value. Power I value. So I is equals for similar question like this only. We have found the value of I2. I think. Wait a minute. We have find the efficiencies. Find the if the secondary voltage. Find the primary current. I1 we have found here. So here we have to find I2. So I1 divided by K. Similar formula. This formula we have to substitute. See. Command V. Okay. I will check the 1 second formula. So I1 for we found previous question we found the I1 as a 40 amps. In case of I2, here we can find I2. How means same formula V2 I2 cos phi, but the value what we obtained after multiplying this uh, after getting the I2 same formula we using this one only cos pi. P is I is Vi cos pi. Substituting this, the given mentioned that 80% is its efficiency. So value obtained will be multiplied. The obtained current will be multiplied with 0.8. So after placing that, that is a 4 kV divided by secondary voltage they have mentioned as 240. So 4K divided by 240 is the voltage. So I will be equals to 13.33. Okay, 4K divided by 240 will give you 13.33. But the answer, sorry, the not 13.33. It will be about 16 point something. I will take calculate. Sorry, divided by 240. It will be 16.67. Then this is the secondary current, but there will be losses. They are given mentioned the 80%. So into multiply this with 0.8. So then we will get 13.33 answer. So answer is 13.33. If you don't understand means if you don't understand this, text comment me, so I will explain once again separately these problems. Okay. Okay, formula used is only this one, P is equals to VI cos phi. So remember these are the main formula. From there we will find the value of I, and 4K is the power, and 240 is the secondary voltage. Then we will get 16.67. Efficiency is given is 80%. So the secondary voltage will be 13.33 amps. So answer is 13.33 amps. Okay, 18th question. A 2000 slash 200 volts, that is primary is 2000, secondary is 200, is a kVA, sorry 20 kVA, that is kilo power is the 20 kVA. Ideal transformer 66 turns in the secondary. The number of primary turns. Here they are asking for finding the number of primary turns. We know the formula that, okay, uh, as I said in earlier, while finding the value of K, V2 divided by V1 will be equals to N2 divided by N1. So here they are given V1, V2 and N2. We are only value we have to find is N1. When we cross multiply this, okay, V2, V1. So okay, we have to find the value of N1. So what I am doing is I am sending this N1 this side. So V2 will come below this, and V1 will be into N2. So V1 into N2 divided by V2. So value will be answer. You can use the calci if you need it. This is the formula. Only we need to cross multiply. We will get the value. So answer is 660 turns. Easily we can find that. They have said the prime second. This is a step down transformer. They mentioned 66 turns in the secondary. This both are same values. Only the extra 0 is added, means it is 100 times of that, 10 times of that more than the secondary value. So we can easily directly 66 means we can put that directly 0. We can directly, no need for any formula like that. Logically we can put directly 60 for this question only. Next question, what is full load secondary current? We have to find the secondary current I. Same formula where we have to use 20 kVA, the given power and the voltage, and the terms that I have mentioned. What they ask is full load secondary current. Full load secondary current I2 we have to find. So I2 will be equals to I2 is equals to P divided by V2. Okay, V2 is equals to P divided by V2. We are considering cos pi as the 1. So P is equals to 20 kilowatt, that is 20,000, divided by V2 is 200. So the value will be, we'll get the answer as 100 amps. How means is equals to P is 200, how much, 20 kV, okay, 20,000 divided by 200. Okay, here we can say that 200 ones are 200 hundreds are 200 100, 210 okay, 2 tens are is 2000, 200 hundreds are is 2 into 100, 200 into 100 will gives you 20,000. So answer is 100 amps. Next question, this is last question. Okay, for same question, for this 18th question only, what is the full load primary current? Full load primary current. Here we can use simple formula as I said earlier, that is I1 will be I1 will be equals to K times of I2, or you can directly found as a previous like this one. Here what a full load primary current. Primary current we can find this. Here the P is we have to find how means same formula I2. So here we have to find I1 primary current. I1 is equals to P. P is the value of 20,000 divided by, what is the value of primary voltage is 2000. Okay, 3 zeros cancel. 20 divided by 2. 2 ones are 2 twos are. So, sorry, 2 ones are 2 twos are. Answer will be, sorry, 2 ones are, so confusing. Okay, I will say 3 zeros cancel. Remaining is 20 divided by 2. 20 by 2. 2 ones are 1. So 1 0. Value will be equals to 10. 2 tens are 20. So answer is 10 amps. If you don't understand any problems, comment. I will do once again. If you have any doubt also, you can comment. I will answer it. Thank you.